Hello students, welcome to section 4-3 multiplying matrices. Today we're going to be multiplying matrices both by hand and also with the tools that I've shown you both on OneNote and the graphing calculator online, and the handheld graphing calculator as well as at your disposal if you happen to have one. So let's take a look. You can multiply two matrices if and only if the number of columns in the first matrix is equal to the number of rows in the second matrix. We'll talk more about that, but essentially, more specifically, I guess, let's say we had a 2 by 3 matrix times a 3 by 2. You can, in fact, multiply a 2 by 3 times a 3 by 2 because the second number in the first matrix, the dimension that I noted, the 3, that's the column value. That number is equal to the 3 in the second matrix I said, the row number. So a 2 by 3 times a 3 by 2, you can multiply, but only because those numbers, 3's, for the two 3's that I noted are the same. And the answer actually ends up being a 2 by 2. Kind of interesting how that unfolds. But that's just a preview of things to come. Kind of generically speaking, they show here, A, B, C, D as matrix A times matrix B, again, E, F, G, H, but a 2 by 2 times a 2 by 2 is fairly straightforward because the second number in the first matrix, the dimensions, N, is equal to the first dimension value in the second matrix. The answer will end up being a 2 by 2 anyways. A, B, and E, G will be multiplied, particularly in context first, and here's how. A times E plus B times G. As you can see, that's the first kind of spot in the resulting matrix. So if you add those two quantities, that's the number that you'll find in the first row, first column, as your answer speaks to. Then you continue on this particular row again, but now times the next column over in the second matrix. So A times F plus B times H. And you can see that here, AF plus BH. And so on. CD and EG multiplied and added such that C times E plus D times G, you see that there. And then again, CD, but now times FH. So C times F plus D times H. And that's that last entry. So let's do an example. It says find AB if matrix A is this 1, 2, 3 by 2 matrix. So three rows and 2 columns. Matrix B is a 2 by 2. Okay, so 2 rows, 2 columns. Because this is a 3 by 2 and this is a 2 by 2, yes, you can multiply because the second dimension value on this first matrix is equal to the first dimension value on the second matrix. So it will end up being, as an answer, a 3 by 2 matrix. You take the M of matrix A and the N of matrix B, and that's the final row by column measurement. So here's the setup. So AB is equal to, here's the first matrix A times matrix B. So the math works the following manner. Again, negative 4, 3, that's row 1. You're going to multiply and add times this first column in the second matrix. So negative 4 times 5 plus 3 times 1. And that particular value, well, if you do the math, you have negative 20 minus 3, so negative 23. Continuing on. Same row in the first matrix, negative 4, 3 times the now second column in the second matrix. So negative 4 times negative 2 plus 3 times 3. That math lends itself nicely to 17. And the process continues. This row times that column, technically it's times and plus, as we noted. So 2 times 5 plus negative 2 times negative 1. Moving on, this particular row times now the next column over. Here's the next setup of math. And then you continue on down, 1, 7, and 5, negative 1. There's the products and addition of values. And then 1, 7, and negative 2, 3, which you see there in the last little setup. The final answer, like I said, is in fact a 3 by 2 matrix, of which is negative 23, 17, 12, negative 10, and negative 2, 19. Again, a 3 by 2 matrix results. I am going to show you this on the graphing calculator, as I've done for you in the past. Both on the graphing calculator, we'll start with this. If you happen to have your handheld graphing calculator, I advise that you try this out. If you don't, and if you've already downloaded this, I advise you try the same process, but on this downloaded computer version of the graphing calculator. So I'm going to hit second, X inverse. We're going to go to Edit, Matrix A. And Matrix A, again, was a 3 by 2. So let's enter it in exactly as we see. Negative 4, 3, 2, negative 2, 1, 7. Okay, once you type in your 3 by 2, I'm going to ask that you, or recommend, excuse me, that you quit the matrix. So second quit. Go back in the matrix, hit second X inverse again, edit, and then option number 2 for matrix B. So let's type in, again, well, it's 2 by 2. With the appropriate values, as you hopefully can see here, we've got 5, negative 2, and we've got negative 1 and 3. So once you have these typed in, I'm going to go ahead and quit yet again, get out of the matrix. And we go back in the matrix, and I'm going to hit option 1, so A times option 2. Are we able to do this? Well, the calculator should show you that yes, the answer is in fact the same as we just saw. Now, if I were to flip the order around, watch this. If I were to multiply B times A, this is a crucial thing to take a look at. If you multiply B times A, think about this. You're multiplying a 2 by 2 times a 3 by 2. The second dimension value of a 2 by 2 times the first dimension value of a 3 by 2 are not the same. A 2 by 2 times a 3 by 2 is not possible. It's an error in the dimension mismatch. So that then hopefully is bringing more clarity as to kind of the operations that we can and maybe cannot perform in context. If we were to do this on the just the OneNote matrix tool option that I was showing you guys, and I don't necessarily have to use the same values, although it might be nice to kind of do that here. I'll insert equation. We'll pick our structures, bracket, and we'll pick our square brackets. We'll enlarge. It's a bit of a process, but once you get the hang of it, this might end up being even quicker than the graphing calculator actually. So let's try this out. So I'm going to have a matrix, let's just say A, of which we said, if you recall, easier said than done, right? So we have matrix A. Actually, let's try this. Let's make my life even simpler than that. How about I do a quick little snip of both respective matrices. So that then keep my work a little bit cleaner when it's all said and done here. All right. So if I do this, of course, we can type in, as we saw earlier in previous videos, we've got negative 4, comma 3, 2, comma negative 2. We have 1, 7. And then our other matrix, we can insert equation, our structures, and we'll end up hopefully just as quickly with this 2 by 2 now, 5, negative 2, negative 1, and 3. Notice again, we do need parentheses when we're doing these operations. So I'll go ahead and highlight it, and if you recall, math, and then we'll select the action of evaluating. So there you have it. You can do the same exact thing on the OneNote calculator tool, and I'll go ahead and just insert that here. See if that's not horribly bad. Okay. Move it at a different spot. Okay. So again, these tools are available to you. You might find this easier than maybe the graphing calculator as you proceed with, with various questions. That's again at your disposal if you so choose. Let's go ahead and take a look at the second side of our notes. As we continue on, it's going to dig more deeply into multiplying. There's multiplicative properties that we need to take a look at. The commutative property of multiplication does not hold for matrices. If you remember the commutative property of multiplication for just, numbers, for example, we know that 3 times 4 is equal to 4 times 3, just as an example. As I displayed on the graphing calculator, and as I discussed with dimension analysis and discussion from the very beginning, if the second dimension value is not equal to the first dimension value in the first versus second matrix expressions that you're multiplying, it can't be done. It's a dimension mismatch. These are all the properties that we're going to be kind of taking a look at. Properties of matrix multiplication for any matrices A, B, and C, for which the matrix product is defined, and any scalar C, the following properties are true. So we can go ahead and do an analysis of the associative property as such. A times B times C, and again, these are all matrices we're looking at, is in fact equal to A times the quantity B times C. So really just moving the grouping symbols is acceptable. Keep in mind the commutative property would not be acceptable. So we're just moving the parentheses. The associative property of scalar multiplication. So if you have a C scalar just multiplied by two matrices, so a number times A times B, it is also acceptable to write it as C times A in parentheses times B, but also A times C times B. So if you just multiply the scalar times B as opposed to just times A, that's going to work. Left distributive property and right distributive property. It does boil down to if you have a matrix on the outside of the sum of two additional matrices, you can distribute that matrix through accordingly. And the same holds true, but be careful. The order does matter. So even though you're distributing the C on the left distributive property, the C is distributed, but in such a way where A is still on the left side. So A times C, there it is, and then B times C. All right, in the example, it says here's A 2 by 2, B a 2 by 2, and then C a 2 by 2. The question does walk you through for part A and C. For part A plus B times C. Now, I will argue that this can be done very quickly on the calculator, but I want to briefly kind of highlight how they've done this. Not exactly with all the math per se, but at least with using the properties appropriately. So here's a 2 by 2 plus another 2 by 2, and then outside of those parentheses, here's another 2 by 2. So of course, a 2 by 2 plus a 2 by 2 is acceptable. That's the only way that you can add matrices if the dimensions are equal. And then once you get that result, which apparently is right here, you have another 2 by 2, of course. Then you do matrix multiplication. So it's 6, negative 3, 7, negative 2, times 1, negative 2, 6, 3. This row times this column ends up looking like this, and of course also adding, and then keep going. This row times this column, there's the products and sum there, and then the next row down times the first column again, there's that particular value, or the value in the next step you could see is negative 5, and then keep going, that same row, but then times the next column over, and there you have it. So this is the resulting 2 by 2. In part B, you're going to be taking a look at a little bit more in-depth analysis of A times C plus B times C, but it's all plausible because this is going to end up being plausible. A 2 by 2 times a 2 by 2 is a 2 by 2. The same here. You add these two because, well, the dimensions are identical and you end up with this. Note that although the results in the example illustrate the right distributive property, they do not prove it. Concludes today's note.